Stephanie, you're muted if you're trying to talk.
Oops, my bad. I was trying to talk, but I'm just gonna wait a few minutes until like some more people come in for the math class.
So I think my class will be coming up in a couple of minutes, so let me just start sharing my content. Can I have host now?
Wait, Tina, just give me a few minutes before you start. I'm gonna tell them something first, and then you can share your screen after.
Oh, okay.
All right, hi everyone. Before we begin, for those of you guys who are not here for the last class, I just wanted to make a small announcement. So let me share my screen real quick. Oh wait, did E10 leave already? Oh wait, Tina, can you make me a co-host? Okay, thank you. So now I'll go ahead and share my screen. So if you guys were here for earlier or for the class yesterday, I talked about how I wrote my own book on public health and epidemiology, and it's officially on sale now. You can find the link on the Kid Teach Kid website. It should be kidteachkid.org/epidemiology-unmasked. And then I just encourage you guys to buy it because it serves as like the official textbook for our public health class. And also it's been endorsed by a few professors, and all the proceeds are going to be donated to help fight COVID-19. So it's a win-win situation for all of us. And also Rich may send out like another email today or sometime later that'll discuss how we're going to be implementing a system called the point system, where Kid Teach Kid students can receive points by participating in a bunch of activities that we have. So buying the book would count as one of the activity, and we'll just track that by asking guys to fill out a quick form. So in general, in summary, I mean, I would really appreciate it if you could check out my book. It's I would recommend you get the ebook version because the paperback will take a long time to ship. So yeah, let me send you guys the link to the book in the chat real quick. All right, I think it's getting buried, so I'm just gonna send it again, and please don't spam so that people can see the link. All right, thank you guys, and then I'll just let Tina start with her class.
Okay, thanks, Stephanie. Okay, so I'll be teaching Math Competition 1, and this week we'll be finding areas with similarity. My name is Tina Lee, and I'm a rising freshman at Clemens High School, and I'll be teaching this class for the next 4 weeks. Okay, so today we'll be going over areas. We'll be going, so if we have a triangle like this, and the base and the height, we know that the area will be base times height over 2, right guys? And we'll be using this formula for the majority of our questions today. And so if we use this formula, we also get that if we have this triangle here, let's call it ABC with D. Okay, so if the base of triangle ABD is X and the base of triangle ADC is Y, then we have that the height is H. We have that the area of triangle ABD is XH over 2. The triangle of ADC is equal to YH over 2. And the triangle of ABC would be equal to X plus Y times H over 2. Okay, so if we express this in colors, we have that the yellow triangle is ABD and the red triangle is ADC. And then we can just have the green triangle as the biggest triangle ABC. So when we're looking at the ratio of the areas, we have that the yellow triangle to the red triangle to the green triangle is X to Y to X plus Y. And we'll be using this later on in our problems. And then now let's go on to similarity. A lot of you probably already know what similarity is, but I'll just go over it again just in case you guys don't. So if we have triangle ABC and DEF, we say that two triangles are similar if all of the angles correspond to each other, and all of the ratios of the sides are, and the ratio of the sides are all equal, which means that AB over DE equals AC over DF equals BC over EF, right? So the ratios should all be the same. And we can tell that two triangles are similar by 3 ways. We have angle, 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 which means that if we have angle, which means that if two angles correspond to each other, we know that the third angle will also be equal because all of the angles of a triangle add up to 180 degrees. And then the next one is sine angle side, which means that if this side and this side have the same ratio as this side and this side, and also the angles are the same angles, then we know that it is similar. And lastly, we have side, 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 which is when all 3 of the sides of the triangles all have the same ratio, which is this. So when we have similarity, that means that all the ratio is the same. So if this length, BC, let's call it like X, we know that E and EC is Y. We know that the ratio will be X over Y for all of the lengths on the triangle. So we can use this to find the ratio of the areas. So let's call this side X, right? And then let's call this side Y. Wait, actually, to make this easier for you guys, I can call this triangle AX, right? So that we have the ratio is x over AX equals 1 over A. So then the height of this triangle, let's denote it as H. We know that the height of this triangle is AH because all the lengths in the triangle have the same ratio, so it's H to AH. Using the area formula from the beginning, we have that the area of ABC equals XH over 2, and the area of DEF equals A squared XH over 2. So when we look at this, we realize that the ratio of the area is 1 to A squared. But we also realize that the ratio of the lengths is 1 to A. So we see that, so we're able to see that the ratio of the area is the ratio of the length squared. Okay, so do you guys understand that? Do you guys have any questions? No? Okay, well, that's good. Now let's start with the next problem. Let's start with this problem. So this is a relatively simple problem, and I'll give you a couple seconds to read the problem. We have a point D on BC so that the perimeter of ACD is the same as the perimeter of ADB. And we want the area of ADB. So I'll give you a minute to think about the problem first. Okay, so let's start on the problem. If we have CD as x, we can have DB as 5 minus x, and we can have AD as y. So can someone tell me what the perimeter of ACD would be? Okay, well, the perimeter of ACD would be 3 plus x plus y, and the perimeter of ADB would be 4 plus y plus 5 minus x, right? Okay, so simplifying this equation, we can cancel out the y's and then move the x to one side to have 2x equals 6, so x equals 3, right? So x here, we can replace it with 3, and then we have 5 minus x, we can replace it with 2. Now, we can draw this height as h, right? So we know that the area would be the area of ABC would be 5 times h over 2. And also we have that this is a right triangle because it's a 3, 4, 5 triangle, so it's special, so the angle is 90 degrees. So we have that this equals to 3 times 4 over 2, right? Solving for h, we have that h equals 12 over 5 when we solve for this equation. And then we know that the area of this triangle would be the base, BD, times the height, A, times the height h. So we have that it would be 2 times 12 over 5 over 2. And then we would be able to find that this is equal to 12 over 5, which is D. So do you guys have any questions about how we solve that? Okay. So now let's move on to the next question. We want to find the area of the shaded regions. So I'll give you guys some time to look at the problems right now. So let's start. We can draw this line, and we can also draw this line. So when we look at it, we only have 4 triangles, right? And then we also know that this shaded region is the same as this shaded region by rotation, so we can rotate it. And since we can rotate it to get to the same thing, we have that this point is the center of the entire rectangle, right? So we can draw the perpendicular to this side, so it can be the height of this triangle, and then the perpendicular to this side, so it can be the height of this triangle, and then the perpendicular to this side, so it can be the height of this triangle, and then the last perpendicular to this side. So we know that this entire side is 5, right? So that half of this would be 5 over 2. And then we know that this entire side is 8, right? So the half of it would be 4. So if we focus on this triangle first, right, we have it's 1 times 5 over 2 over 2. So 1 times 5 over 2 over 2. And this is equivalent to 5 over 4, right? And then if we look at this triangle, the green triangle, we have that it's 1 times the height, which is 4 over 2. So we get that this is 2. So we know that the whole shaded region of this part would be equal to 2 plus 5 over 4. And then since we know that this is the same thing but rotated on the other side, we can multiply this by 2 to get our final answer. So it's 4 plus 5 over 2. And can anyone tell me what this simplifies to? Okay, you guys are good. It's 6.5, which means our answer is D. All right. Now we can move on to the next problem, and this one is a little bit harder. I'll give you a couple seconds to read it, and we know, so in triangle ABC, point D divides AC such that AD to DC is 1 to 2, and let E be the midpoint of BD, and let F be the intersection of the line BC and AE in the line AE. Given that the area of triangle ABC is 360, we need to find the area of EBF. So I'll give you a couple seconds to look at the problem to see if you guys can figure it out. But I think that's been enough time for you guys to look at and think about this problem. So we can draw line EC here just to help us. So do you guys remember in the beginning of class, I said that in a triangle like this, if it has the same height, then the ratio of the areas would be the ratio of the bases, right? So we have that the ratio of ADE over DEC equals 1 over 2, right? So we can have that if this area is X, this area would be 2X. And then by the same logic on triangle ABD, we have that triangle ABE over triangle AED would be equal to 1 over 1, right? So this would also be X. Now, if we look at the whole triangle ABC, we can again use the same concept to get that the area of triangle ABD over the area of ABC would be equal to AD over AC, which is equal to 1 over 3, right? because DC would be 2y, and then AD would be y, so it's 1/3. Okay, so if we all already have these ratios, can somebody tell me what x would be in this triangle if the total area is 360? Okay, since ABC is 360, we have that ABD would be 120, right? So the area of triangle ABD would be 120, so 2x equals 120. So that means that x equals 60. How do I know that ADE has the same height as EDC? Because if we draw this height here, it's h, right? And they have this as the base. So if you look at it from sideways, you know that this h is both the height of AED and the height of DEC. Do you guys get that? Okay, good. So now we know that x is 60, right? So we have that, instead of writing it as x, we can write it as 60. And we can write this as 120. And then let's call BEF like A. Let's call it a variable A, right? And then we can have this. Okay, let's go to this side. We have that the area of BEF to the area of EFC would be equal to BF over FC, right? By the same logic that we just used. And then from here, we can also look at the bigger triangle. You can look at the bigger triangle. And then we can see that ABF to AFC is also equal to BF to FC. Okay, so if we call this B, we have that A over B equals BF over FC, which is also equal to ABF over AFC. So you can add it and B, and so that, like, what would the area of ABF be, guys? It would be 60 plus A, right? If you guys are paying attention. And then we also have AFC. And then can someone tell me what that would be? The area of AFC. Okay, yeah, it's 180 plus B. Good job. So then cross multiplying would get us 180 A plus AB equals 60B plus AB. And then canceling out the AB, we have 180 A equals 60B. So 3A equals B, right? So instead of writing this as B, we can write it as 3B. So now we have the, I'm sorry, it's 3A. So now we have that 4A plus 60 plus 60 plus 120 equals the whole triangle's area, which is 360. So from there, we can get that 4A equals 120, so A equals 30. So the area of BEF would just be 30, which is B. Is that good, guys? You guys have any questions? No? Okay, that's good. Okay, so now we can look at this problem. I'll read it to you guys, and then I'll give you guys a little bit of time to think. So 1-inch squares are cut from the corners of this 5-inch square. So what is the area in square inches of the largest square that can be fitted into the remaining space? So like if we draw a square like this, Okay, so we want the area of that square, right? What is the largest area? Okay, so I am seeing a lot of different answers, but mostly B. So I think we can start by drawing the inner square here, right? My diagram is not amazing, so you guys probably can't tell, but this, all of the sides of the square passes through the vertices of these 4 little squares, right? So since this is a 5-inch square and 1-inch squares are all cut off, you know that this length is 1, this length is 1, so this length is 3, right? And this is 3. So the very middle triangle would be 3 times 3, which is 9. And then now we want each of the 4 bigger triangles here, right? And they would all be the same because it's a square, so it would just be the same rotated. So if we draw the height of this triangle, we know that it is 1, right? Because this, since it's a 1-inch square, this is also 1. So we have 4 times 1 times 3 over 2, right? Is that good? So if we multiply this out, we have that 9 plus 4 times 3 over 2 equals 9 plus 6 equals 15. So the answer would be C. Do you guys see how that is? How that is? Okay. So yeah, it was a fairly easy 25, number 25, but it was also an AMCA question. So do you guys want like a little break right now until 3:30, or do you guys want to go to the next question immediately? Okay, yeah, so we can just take a break until 3:30 and then we can continue with the rest of the questions. Okay, guys, it's already 3:30, so break is now over. Okay, so let's look at this problem. In triangle ABC, point E is on AB with AE equals 1 and EB equals 2. And point D is on AC such that DE is parallel to BC, and point F is on BC such that EF is parallel to AC, right? So you want the ratio of the area CDEF to the area of ABC. So we can start by looking at these really suspicious parallel lines. Okay, so we know that when these lines are parallel, this angle is equal to this angle, right? Because it's a transversal. And then similarly, we have this angle, right? So we can say that ADE is equivalent to another triangle, ACB. Right? So we have triangle, triangle ADE is similar to triangle ACB by angle, because they have two angles that are the same, which is angle A and angle ADE, and also angle A and angle ACB. Can you guys see that? Okay, good. So then now we have that the area of ADE over the area of ABC would be equal to the ratio of the sides squared, which would mean 1/3 squared, right? So then this is 1/9. So we know that ADE is 1/9 of the entire triangle. So we can just write 1/9 here. And then similarly, we can say that since BC is a transversal, we have that BCA is the same angle as BFE, right? And then we know that B here is this is also a triangle, is also an angle of both triangles. So now we can write that triangle BEF is similar to triangle BAC, also by angle. So you guys see that, right? And then now we can do similarity again to get that the area of BEF over the area of the entire triangle is equal to the ratio of the sides, which is BE over BA squared. And this is equal to 2/3 squared equals 4/9. So the triangle BEF is 4/9 of the entire triangle. Now we have ABC. If it's the whole of the triangle, it'd be 1, right? And we want to find the area of this parallelogram. So we need to subtract the areas of these two triangles. So 1 minus 1/9 minus 4/9, right? So what would this equal? Okay, you guys got it right, yeah. So this would equal to 4/9, which would be the ratio of the parallelogram to the bigger triangle, which would be A. You guys got that? Does anyone have any questions? No questions? Okay. Now we can go on to this problem. This is point E is the midpoint of side CD in square ABCD, and BE meets the diagonal AC at point F, right? And then we know that the area of AFED is 45, and we want the area of the entire triangle. So I'll give you guys a couple seconds to just think about the problem first. So I think we can start now. So if we know that AB, let's first call this ECX, right? The base X. And then now we know that AB is twice that because E is the midpoint, so AB would be 2X. And now we can look at ABF and FEC. Since CD and AB are parallel because it's a square, we have that this angle equals this angle, and this angle equals this angle. So we know that triangle ABF is similar to triangle CEF, right, guys? Okay. And then we know that it's similar by a factor of 1 to 2, right? Because EC over AB equals 1 over 2. So we have that the area of triangle CEF over the area of triangle ABF, this would just be equal to 1 over 4, right? Because it's the ratio of the length squared. So let's call this X. You know what? Let's not use that variable. Let's call this S. Call this S, and let's call this 4S, right? Okay, now we also know that we have EF over FB is also 1 to 2, right? Because we have that these are similar. Okay, so we know that this side, let's call this side A. BF would be 2A because the two triangles are similar. And now remember, since now we can look back to the beginning of our class to know that if this is A and this is 2A, then the ratio of the side would be 1 to 2. So the ratio of the areas would also be 1 to 2. So this is 2S, right? Okay, so that's good. So we have that. Now we have that the area of triangle BEC would be equal to 3S, right? But if we split our square like so, we would be able to see that triangle BEC. We would see that triangle BEC is only 1/4 of the entire area. Right? So we see that triangle ABCD would be equal to 12S. Right? So then we know that it's 12S, and we need to subtract the areas that we have already found to find the area of ADEF in terms of S. So 12S minus 4S minus 2S minus S would be equal to 5S. So 45 equals 5S. Now, looking at this, we can have that S equals 9. So when we want the area of ABCD, we have that the area of ABCD equals 12 times 9, which is 108. Right? Which means that the answer would be B. So All right, so do you guys all get that? Do you guys have any questions? Oh, for anyone asking what S is equal to, S is just a variable that we assign the area of EFC. Okay, so we're done with this problem. Now let's go down to this problem. This was in 2016's AMC 8, number 22. So rectangle DEFA below is a 3x4 rectangle with DC equals CB equals BA. What is the area of the bat wings, which is the shaded region? So I'll let you guys think about that for a couple seconds. Okay, so let's get started on this problem. So let's first start by drawing the heights to EF and BC. Okay, so now when we look, we can just start by finding the areas of the non-shaded regions, right? Like for example, ABF. We know that the base is 1 times the height is 4 over 2, so it's 2. We can find that easily, right? Okay, and now the harder part would be to look at, let's call this point, let's make up like a nice name for it, G. So triangle EGF, we want to find the height of it, right? So first we need to look at it and think that, like, since it's a rectangle, AD and EF are parallel. So that means that we should be looking for similar triangles. So we need to see what GEF is similar to. And if we look, the only other triangle that is there is GCB. So these two triangles are similar because this angle is equal to this angle, and this angle is equal to this angle. So it's similar by AA. Now we know that EF is 3 and BC is 1, right? So we have that this height, let's call this point X and this point Y. We have that the height GX over GY would be equal to EF over BC because the triangles are similar, which means this is 3. So let's call this, we can use a variable like H. This is 3H, and then this would be H, right? Since it's 3 to 1. Now we know that 4H would be equal to 4, which is because it's the side of the rectangle. So we know that H is equal to 1. So we want to find that the area of GEF would be equal to 3 times 3 over 2 equals area of GEF, which means that this is equal to 9 over 2. And then we also want the area of BCG. BCG equals 1 times 1 over 2, which is 1/2. So we know that the total area of ADEF is equal to 12, right? And we want to find the area of the shaded regions, which is just the area of the entire triangle minus the area of ABF minus the area of CDE minus the area of BCG and minus the area of GEF to get the shaded regions. Now looking at this, we have that it is 12 minus 2 minus 2 minus 9.5 minus 1.5. So we can see that this is 12 minus 2 minus 2 minus 5, which is equal to, can someone tell me the answer? What would this be equal to? Oh yes, it's 3, which means that the answer would be C. So does anybody have any questions? Okay. Now let's go on to the final problem. We have triangle AMC is isosceles with AM equals AC, and medians MV and CU are perpendicular to each other, and MV equals CU equals 12. So what is the area of AMC? So I'll let you guys just think about that for a minute. Okay, I think that was enough time for you guys to think. So we have that AM equals AC, and medians MV and CU are perpendicular to each other. So they meet at a right angle. And MV and CU equals 1/2. So what is the area of AMC? We know that since these are isosceles, all of these lengths are equal. And then if we draw UV here, we have that UV would be parallel to CM because these triangles would be similar. Because this angle, we would have this by SAS similarity. So triangle AUV is similar to triangle AMC, and the similarity ratio would be 1 to 2 because it would be 1 to 2. Now looking at this, we have that if MC was 2x, we would also have UV as x, right? So if this was x, we also have that UPV and MPC are also similar because this angle is equal to this angle, and these angles are the same because they're parallel. Do you guys get that? They're parallel because the AUV and AMC are similar, so these two angles are parallel. Now looking at this, we can see that PV over PM equals PU over PC equals UV over MC equals 1 to 2, right? Because the triangles are similar. Let me write that. Triangles PUV is similar to triangle PCM. Now when we have that this is similar, we know that PC is actually CU minus PU, which is equal to 12 minus PU. So PU over 12 minus PU is equal to 1/2. So 2 PU equals 12 minus PU. So 3 PU equals 12, and PU equals 4. Right? So this is 4. And then since PU equals 4, PC would have to equal 8. Do you guys get that? Okay, good. And now if we look at MV, we can conclude that it is the same because MV is 12, and if we use the same thing, we can get that this is equal to 4, and this is also equal to 8. So now multiplying using base times height, we have that the area of PUV equals 8, and the area of PCM equals 32. This is 32, and this is 8. And now looking at triangle PVC, we find that triangle PVC is actually 2 times triangle PUV because in the beginning of class, we found that since they share the same height, their areas would be the same as the ratio of their lengths, of the lengths of their bases. I don't know why my pen just isn't working right now. Wait, give me a minute, my pen is like malfunctioning. Okay, my okay, so yeah, I fixed it. Now we can see that triangle PUV over triangle PVC would equal PU over PC equals 1 over 2, right? And since we know that PUV is equal to 8, we know that PVC is equal to 16. Okay, so let's erase some of these extraneous numbers, and we can just have that this is 4. Wait, no, sorry. This is 8, this is 16, this is 32, this is also 16, right? Because it's the same, just flipped. Now, if we add these all up, we get that the area of MUVC is equal to 72. Okay, and now let's look at the area of AUV because we found the areas of everything else except for AUV. So AUV over AMC would have to equal AV over AC squared, right? Do you guys get why? It's because in the beginning we found that the area ratio is the ratio of the lengths squared. Now this is equal to 1 over 2 squared, which is equal to 1 over 4. So that AUV is only 1/4 of the entire area of AMC. So we can find that MUVC is 3/4 of the area of AMC. So 72 equals AMC times 3/4. So we can multiply this by 4 over 3, multiply this side by 4 over 3 to cancel out this side to get that it would be 96. So the answer would be C, 96. So does anybody have any questions? Oh, so how do we know that the triangles are right triangles? We know because in the problem it states that MV and CU are perpendicular, and perpendicular just means that they meet at a right angle. Is that good? Okay, so the class is ending, so I'll just let the next person take over.